Hi everyone. We've got the graphs of inverse functions. So we've determined, remember, um, that f of the inverse of f of x is equal to x, and the inverse of f of x is also equal to x. Okay, so on the graphs, there's some interesting things that happen here. The graph of f and inverse f relate this way. If AB, if this ordered pair is on f, and it's the solution of f of x, then BA, we switch the x and the y's around, is on the inverse of f of x. Alright, the graph of the inverse is a reflection of the graph of the function f over the equation y equals x. I got a few examples. One, I just have an example written here. Note that I got 0, negative 2. Negative 2, 0. Negative 1, 1. I've got 2, 2 as a point. Let's see, that is 3, 7, I think. No, 7, 3. 1, 2, 3, 4, 5, 6, 7, 3. And this, I believe, is 14, 4. 8, 9, 10, 11, 12, 13, 14, 4. I may just write that down there. And this was 7, 3. This was 2, 2. Okay, this curve is a function. And if I were to graph the inverse of this function, all right, what I want you to see is y equals x. Let me change colors here. Okay, if I reflect this point, if I take a diagonal right to that point and then go that diagonal on the other side, this is the reflection of that point. And then let's look at the reflection of this point. I go here, and diagonally I go here. If I reflect this point over the line, it is on the line. So that stays there. And if you look right here, I kind of goofed on where I placed this. If I graph here, if I go 2 diagonals here, and I would go 2 diagonals on this side of the line, I would have this point right here. So if you kind of take a look, and this one's way out there, so I'm not going to bother trying to get that one plotted, given the room I gave myself here. So it kind of starts here, and then, let's change colors again. Kind of goes like this. And that kind of gets me from here to here. These are the inverses. And notice, does it look like this is reflecting over this line, y equals x? Now, the y equals x line, I don't know if you caught that, but it's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. The y and x coordinates are the same. Negative 1, negative 1, negative 2, negative 2. But notice how those reflect. So you can just graph it right away. Okay. Now example 2 here. It says verify graphically that the functions f of x, which equals 4x minus 1, and g of x equals 1/4 times x plus 1 are inverse functions. That says verify graphically, so let me draw an x and y coordinate plane here. I'm going to graph function f. Let's graph it in red. F is in red. And the y-intercept's negative 1. And the slope is 4. 1, 2, 3, 4. Go up 4 over 1. Let me do that a couple times. 1, 2, 3, 4, and 1. Let me go down. 1, 2, 3, 4, and 1. And then just be somewhat careful here making this. So there's that line. Why, this is f of x. Okay. Now g of x. We're going to try to verify that graphically. G of x equals 1/4 x plus 1. So if x is 0, I'm going to just kind of informally use a table here. Let's go a few. Let's go like -2, -1, 0, 1, 2 for x and g of x, the x and y there. -2 plus 1 is -1, and a fourth times -1 is -1/4. -1 plus 1 is 0, and a fourth times 0 is 0. 0 plus 1, so 0 plus 1 is 1, times 1/4 is 1/4. 1 plus 1 is 2. 1/4 times 2 is 1/2. 2 plus 1 is 3. So that goes 3/4 there. So -2, -1/4, right around there. -1, 0 is there. 0, 1/4 there. 1, 1/2 there. 3/4. Okay, now the slope, I'm going to go up 1/4 here. The slope is 1/4. And I do have that -1, 0. So let me go down 1 and 1, 2, 3, 4. I get another point there. I might do that one more time. 2, 3, 4 there. And go up 1, 1, 2, 3, 4 there. Okay. So there is that. Now it said verify graphically. Y equals x. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. Now you notice 1, 2 and a half, 1, 2 and a half on that side too. It looks like they are reflections of each other. And the other thing I want you to notice, some of these key points here, like this point right here, -1, 1, 2, 3, 4, 5. This point here is -1, -5. If I go 1, 2, 3, 4, 5, this is -5, -1. The x and y coordinates are being shifted around. Right here at 0, -1, on this line we have -1, 0. I believe right here we're looking at well, I'm not real sure what those are, what those two coordinates are right offhand. 1, 2, 3. This point is 3, 1. This point right here, the reflection is 1, 3. Okay, so you got, remember the AB on one side and the BA on the other, if you remember the notes from the last video. Okay. Now, one last one here. Verify graphically that f of x equals x squared plus 1 when x is greater than or equal to 0. Alright, I'm going to make a table for f, x, and f of x. It's greater than or equal to 0, so let's go 0, 1, 2, 3. Let's see how far we can go. 0. 0 squared plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. So let's plot 0, 1 right there. 1, 2, right there, 2, 5, 2, 3, 4, 5, and 3, 10. 5, 6, 7, 8, 9, 10 right there. Alright, let's do that one in f of x will be in purple right now. So they did restrict the domain there for us. So where x is greater than or equal to 0. So that's this function plotted. Let's plot g of x. X and g of x. So x cannot be 0 because that makes it negative, and we're only dealing with the real number coordinate plane. So the smallest value x can be is 1, and 1 minus 1 is 0, square root of 0 is 0. You could go 2. 2 minus 1 is 1. Square root of 1 is 1. Could do 3, 4. I'm going to skip to 5 because 5 minus 1 is 4, and the square root of 4 is 2. 6 minus 1 is 5. Square root of 5 is not a whole number. 7 minus 1 is 6. 8 minus 1 is 7. 9 minus 1 is 8. 10 minus 1 is 9, and the square root of 9 is 3. So I'm just thinking of nice numbers to work with there. So 1, 0 is right here. 2, 1 is right here. 5, 2. Notice 3, 10, 10, 3, 2, 5, 5, 2. This is showing that those are inverses of each other, because it's just flipping the x and y coordinates around. And it's going to also show that it is symmetric around over y equals x. So what do I got? I got 1, 0, 2, 1, 3, 4, 5, 2, 6, 7, 8, 9, 10, 3. Let me do that one in red. G is the red function. Now that increases gradually there. And then y equals x. Let's plot y equals x. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. And notice the reflection of each of these points over the y equals x line. Okay, so that does verify graphically. Reflects over y equals x, and AB is equal to A comma B is equal to B comma A in every case here. Alright, that's that for that video.